Dear student friends, we have studied the chapter of differentiation. Now we shall study the second chapter as successive differentiation. And that means we want to find higher order derivatives. First we shall use a notation for this. Suppose y is equal to f of x be a differentiable function, be n times differentiable function or infinitely many times differentiable function. Be a differentiable function and suppose it has higher order derivatives, n derivative and higher order also. So we denote its derivatives by derivatives with respect to x by the following notation by different notations. As first you consider y is fx, then we denote the first derivative by f dash x. And that we can write f dash x or f prime x. Second derivative we may denote by f double prime or f double dash x. Third derivative we shall denote by like this and so on. The nth derivative we will write in this form, nth derivative of fx and so on. If the derivative exists, then that can be further written. So n times or higher times we can differentiate the function if it is further differentiable, or we may use the notation for y, dy by dx, first derivative we can write. Second derivative we may write d2y by dx square. Third derivative we can write d cube y by dx cube and so on. The nth derivative we write dny by dx to n and so on. This is another notation we know, or we may denote it by y dash, derivative of y, taking y prime, y double prime, y triple prime of x and so on. But nth derivative we write like this, y. We may write the function as x also, it is y dash of x, etc. Or first derivative we write by y1, second derivative y2, third derivative y3 and so on. Nth derivative we denote by y. So these are the different notations to denote the higher order derivatives. And we will follow the last notation, that is y1. We denote the first derivative by y1. These notations are used to simplify the writing expressions, and thus this is simple to write. First derivative by y1 and second derivative by y2, third derivative by y3, and this is nth derivative. And furthermore the n plus 1th derivative will be y suffix n plus 1 and so on. So thus we will follow this notation, and now we shall find out nth derivatives of some standard functions. So these are the successive derivatives or higher order derivatives, and now we shall obtain the formula for nth derivatives of some standard functions. And among these, so we shall first consider nth derivative of of the function ax plus b to the power m with respect to x. This we shall find out. And the method or the procedure to find out the nth derivative is, suppose the function is y, like this, y is equal to f of x. Here y is function of x and that is given as ax plus b to the power m. This is the function that we want to differentiate and we want to find its nth derivative. We will denote the derivatives by this notation. So differentiate with respect to x. Differentiating successively means one after the other, successively with respect to x. We have, now see the first derivative. First derivative is y1. Derivative of this. Differentiate both sides with respect to x. Derivative of y is dy by dx, or that is same as y1. And on the right side, this is the power function ax to the power m. Using the power function formula, we have the derivative as m ax plus b to the power m minus 1. X raised to n. The differentiation is n into x to the power n minus 1. So here it is m and we have used the power function formula. But this is the inner function. We have to use the chain rule also, and we have to multiply the derivative of ax plus b. A, b are constant and therefore derivative of ax is a. Derivative of b is 0. So it is only a. So this is the first derivative. Again differentiate this, we shall get second derivative as y2. Now here what is m and a are constants, and therefore this will remain as it is, and we have to differentiate this function only, ax plus b to the power m minus 1, using the same formula, and therefore this will be m into m minus 1 into ax plus b to the power m minus 2, and again we have to multiply by its derivative, that is a, and that a into this a becomes a square. So you should verify this. We have used the same formula and we have written the derivative of this, and that a into a becomes a square. So this is y2. Likewise, what is the y3? Y3 will be, these are two constants. So we write m minus 1, and derivative of this is derivative of ax plus b to the power m minus 2. So that will be m minus 2 into ax plus b to the power m minus 3 into a cube. The derivative of ax plus b is a into a square is a cube. So this we have obtained y3, and so on. Now this there is a similarity of terms, and by observing these terms we can write what will be the next derivative and what will be the nth derivative. Now see, this is y1. y1 is m into ax plus b to the power m minus 1 into a. y2 is m into m minus 1 into ax plus b raised to m minus 2 into a square, and this is y3. Three terms are there in decreasing order, m minus 1, m minus 2, and ax plus b has power m minus 3 and multiplied by a cube. So and so on. So what will be yn? What the nth derivative we denote by yn, and by observation of this. So it starts, every derivative starts with m and goes on decreasing up to m minus, here it is 3, here it is 2, means one term less, that is up to 3 minus 1, m minus 3 minus 1, and that is m into m minus 2 into m minus 3, m into m minus 1 and into m minus 2 up to, this will be m minus, now see here it is 3, there it is 2, so here it is n, there will be n minus 1. So actually this term will be m minus n minus 1. So we may write in this form, and so this is actually m minus n plus 1. So that is m minus n plus 1. You check it. Into ax plus b to the power m minus 3. Here it will be m minus n. So that is ax plus b to the power m minus n multiplied by a cube. here for third derivative, and for nth derivative it is a to the power n. So this is to be multiplied by a to the power n. So this is the nth derivative we have obtained. Now we shall put this nth derivative in a particular form so as to remember it and use it for other functions also. And for that purpose we consider the earlier product m minus 1 etc. And that we can write as yn is equal to yn. I shall write from this yn as equal to, see, it is m minus 1 and so on, m minus 2 up to m minus n plus 1. Now I shall continue that product m minus n plus 1. What will be the next? And then the term is decreasing by 1, so the next will be m minus n, and we will continue that up to 1. So therefore this is to be written as m minus n, 1 less. And again, so because m is considered as integer here, so this will decrease up to 1, and that will be 3 2 into 1. And we have written few terms extra, and that are to be divided. So from this onwards, the terms we have written extra, and we should divide by extra terms m minus n and so on. That will be m minus n minus 1, decreasing order, and so on up to 3 into 2 into 1. And this remaining terms as it is, that is to be multiplied by, this is to be multiplied by ax plus b to the power m minus n into a to the power n. Now you note this step here, these are the original terms we have written. Further we have added these terms in product, m minus n and m minus n minus 1. I have not written this term here, but it is decreasing order, means decrease 1 every time in each term, and this will continue up to 1. And these terms, these are the extra terms, and we have to divide out by the extra terms, and the value remains the same. So you should know why we have written like this, and that now we can write yn is equal to, so this product starting with m in decreasing order and continue up to 1 is m factorial in factorial function, factorial notation. So therefore this is m factorial. We know factorial, n factorial is the product we can start with 1 1 2 3 up to n, or if you start by n, then in decreasing order it is n minus 1 n minus 2 up to 1. So here it is m minus 1 up to 3 2 into 1, so it is m factorial. And what about the denominator? It is starting with m minus n, then decreases by 1 up to 1. So therefore the denominator will be m minus n factorial, and this is the same, that is ax plus b to the power m minus n into a to the power n. So this is the nth derivative of the function ax plus b to the power m, and we have written it in this form where m is positive integer here. M is a positive integer. And now you see this is nth derivative of y, and we now use the usual notation that we write nth derivative of y means d to the power n by dx n of y. Y is ax plus b to the power n, and that can be written as nth derivative of y is this one. It is the same, and the right side is m factorial. So I shall write this as m factorial a to the power n first, and then ax plus b to the power m minus n divided by m minus n factorial. So this is our first formula for nth derivative of power function. Now we can see the form it is a factorial of m, a to the power n, order of the derivative. And this function ax plus b will have power m minus n. At the denominator, difference of this m and n and its factorial is taken. So this is the first formula we have obtained. Now we shall obtain some results from this main formula, and that what will happen if m is minus 1. Now we will have the corollary to this result. So if m is minus 1, then it will be a reciprocal function. But we can't use the value here directly because minus 1 factorial is not defined, and therefore we have to find out it separately. So our first thing we shall consider what will be if these powers are the same. If m is equal to n, then this nth derivative of ax plus b to the power m means m is n. M is n. And what is the right side? It is n factorial. M is n means n factorial a to the power n. In place of m, write n. Ax plus b to the power m is n means this is 0 power, and divided by m minus n. Both are equal. M is equal to n, so this is 0 factorial. And thus 0 factorial we know it is 1, and this is also 1. So these two are 1, and therefore the result is n factorial into a to the power n. So nth derivative of this function is constant, ax plus b to the power n. Now for example, we can consider the value of a, b, m differently, and you should know how to use the formula. So for example, if I write, say, fifth derivative of the function can be considered as 3x plus 7 and to the power 8. What will be this using the formula? N is there 5, ax plus b is 3x plus 7, and m is 8. So using these values, the derivative will be 8 factorial, m factorial. M is 8, and a is, see here, 3. 3 to the power n is 5. So 3 to the power 5. And then ax plus b is 3x plus 7. 3x plus 7 and to the power m minus n. What is m here? That is 8. And n is 5. So 8 minus 5, and that is 3. So divided by m minus n factorial. Factorial of m minus n. M is 8 and n is 5. That is 3 factorial. So this is the answer. So in that way, by comparison, we have to use the formula. And if I write second as, say, fourth derivative of, what will be fourth derivative of 2x plus say 6, or you may consider any other number, that is 9 raised to 4. Here we may use any one formula, either this one or this one. Here both are equal, power and the order of the derivative are equal, and therefore it is directly n factorial. N here is 4. So 4 factorial into a to the power n. A is 2. 2 to the power. So for this derivative, you may use this formula also, or the second corollary and the first corollary, and therefore the result is the same. So in this way we can use the formula. Now we obtain the derivative of reciprocal function. Second, we may consider as to find nth derivative of nth derivative of 1 upon 1 upon ax plus b with respect to x. let y is equal to 1 upon ax plus b. And this we can write in power form as ax plus b to the power minus 1. So that we can find out the derivatives differentiating successively with respect to x. What we shall get is the first derivative as y1, and derivative of this we know again using the power function formula, minus 1 into ax plus b to the power minus 1 minus 1, that is minus 2 into a. So this is y1. What will be y2? So y2 will be minus 1 is constant, derivative of this function, it is minus 2 into ax plus b to the power minus 3, minus 1 minus 2, and into a, into this a, that is a square. And likewise y3 will be minus 1 minus 2 are constant, this is the derivative of this is minus 3, ax plus b to the power minus 3 minus 1 minus 4 into a square into a, that is a cube, and so on. What will be yn? Yn will be minus 1. It is easy. See, observe y3, minus 1 minus 2 minus 3, and therefore yn will be minus 1 minus 2 minus 3 continued up to minus n. The order and here the term is the same. And to ax plus b to the power, here it is third derivative, the power is minus 4, and for nth derivative the power must be minus of n plus 1, and a power, here it is 3, here it must be n. So this is the nth derivative of 1 upon ax plus b, and we write it in the form as the operator of derivative dn by dx raised to n. So therefore yn means dn by dx raised to n of y. Y is 1 upon ax plus b, and that is equal to, there is no power, only 1 upon ax plus b. Earlier was it was nth power of ax plus b, which is at the numerator, and this is equal to further, but we have to simplify this. And for the simplification, what we can do is, see, minus 1 can be taken common from each term, and that is minus 1 times n, means minus 1 to the power n. From every term we take minus 1 common, and what is remaining is 1, 2, 3 up to n, and that is n factorial. 1, 2, 3 up to n is n factorial. This we should write at denominator with positive power, and this I shall write at numerator, a to the power n, and the denominator is ax plus b to the power n plus 1. So thus this function we have written in that form, taking minus 1 common, minus 1 to the power n, because there are n terms, minus 1 into minus 1 n times, means minus 1 raised to n, and each positive term remains in the product, that becomes n factorial. This is written at denominator, and this is the formula for derivative of nth derivative of the reciprocal function 1 upon ax plus b. Now a corollary to this result we shall write as nth derivative of logarithmic function. So corollary, that means we shall obtain this result from this one, which we have just proved. And nth derivative of log ax plus b with respect to x, and for that purpose let y is equal to log of ax plus b. Differentiate this first once only, differentiate with respect to x. What is the derivative of log of ax plus b? That is y1. Y1 is equal to log function's derivative, that will be reciprocal of ax plus b. Log x derivative is 1 upon x, And similarly, log of ax plus b derivative is 1 upon ax plus b into the derivative of inner function, that is a, and I shall write that at numerator. So this is y1, or we may write this a separately. Now this function is a reciprocal function, and we have this formula of 1 upon ax plus b. That formula can be used to obtain its nth derivative. But the first derivative is obtained. Now how many times we have to differentiate further to get nth derivative? So we have to differentiate furthermore n minus 1 times. So first time and then further n minus 1 times will be total n times derivative. And therefore we write here differentiating this n minus 1 times more, we get this. Now y1 will be yn, because first derivative is already obtained. Further we are obtaining n minus 1 derivatives, so that total derivative order will be n, that becomes yn. And now this a is constant, so we write a first separate. And what is the, or I shall write this as 1 upon ax plus b into a, and this a is written. Now what is the derivative of this? We have here nth order derivative, but here we want n minus 1th order derivatives. That means replace n by n minus 1, and we can use, we may suppose this as equation 1, and using equation 1 write n minus 1th derivative of 1 upon ax plus b, and that we can write, or otherwise we may write first as n minus 1th derivative of 1 upon ax plus b, because what we have written is we are differentiating this n minus 1 times, and this becomes yn. This a is constant, and this is n minus 1th derivative of 1 upon ax plus b. Now use the equation 1, formula in the equation 1. Wherever n is there, replace n by n minus 1. We get n minus 1th derivative using that formula, and thus this yn is, yn means nth derivative of y, and what is y? Log of ax plus b, and therefore, so nth derivative of log of ax plus b is, now what is the right side? So this is the yn means nth derivative of y, and y is log of ax plus b, and the right side is this a can be written as it is, and you see what is n minus 1th derivative of this. Replace here n by n minus 1, and that will be minus 1 to the power n minus 1, n minus 1 factorial, a to the power n minus 1, divided by ax plus b to the power, n is replaced by n minus 1, n minus 1 plus 1, that is n. So that means decrease n by 1, everywhere you have to write n minus 1. So this is the formula, and you see this a into a to the power n minus 1 becomes a to the power n. This minus 1 and plus 1 cancels, so I shall write this as a to the power n. Check it, and this is our next formula, derivative of log of ax plus b. So thus we have obtained two results. Now we consider the next result as nth derivative of exponential function a to the power mx with respect to x. This is simple. Let y is equal to, let y be a to the power mx, and m is constant. Differentiate this successively, differentiating with respect to x, successively with respect to x, we can consider differentiating this successively with respect to x. What we shall get is, first derivative is y1, so we get y1 is equal to, and we know what is the derivative of exponential function a to the power x is a to the power x into log a, and here a to the power mx, the derivative is a to the power mx into log a, and further we have to multiply by derivative of mx. What is derivative of mx? That is m. and thus this is the first derivative. We are using the chain rule and the formula of differentiation. So this is y1. y2 will be again this a to the power mx derivative. Log a into log m is constant, so this will remain the same, and derivative of a to the power mx is again a to the power mx into log a into m, and therefore these terms will be double terms, and it will be square of these two terms. So that is a to the power mx into log a whole square. We must write like this: log a into log a and m square. Repeating the formula, and y3 is a to the power mx, derivative of this a to the power mx into log a into m, and these terms will get multiplied and the power becomes now 3, log a to the power 3 m to the power 3, and so on. What will be yn, so that we can write. See, observe y3, y2, etc. y1, y2, y3. For observation only, we are writing the three derivatives, and then from that we can write directly what will be the nth derivative. For y2, it is a to the power mx log a square into m square. For y3, it is a to the power mx log a to the power 3 m to the power 3, and so on. What will be yn? And yn means I shall write nth derivative of y, and that is, so we may first write yn is equal to a to the power mx, then log a to the power n, m to the power n, and that yn means nth derivative of y, and this is the notation for or symbol for or operator for nth derivative of with respect to x, dn by dx n, and y is a to the power mx and is equal to, we may write the constant functions first, then this will be m to the power n log a to the power n and a to the power mx. So this is the our next formula, and we can write a corollary to this formula as see, nth derivative of e to the power mx. What will be nth derivative of e to the power mx? This by the same, in place of a here is e, and therefore we have to write only that in place of a e we have to write, and mn remains the same, m to the power n log e to the power n and e to the power mx. But we know log e is 1, and thus this is equal to m to the power n e to the power mx, since log e is 1. So thus this is the formula for nth derivative of e to the power mx. So it is easy to write or derive from this main result. So thus we have obtained the derivatives of algebraic functions and exponential functions. Now the remaining part, that is derivatives of trigonometric functions, we shall obtain in our next lecture. Thank you.